Hello, StudyBuds! Welcome again to StudyWorld. I'm StudyBud Miggy, and let me guide you throughout this trip, for we're out again to explore more topics in the world of physics. At the end of this discussion, you must be able to determine the result of adding two displacement vectors, learn how to apply the Pythagorean Theorem in a displacement problem, familiarize base quantities and derived quantities, differentiate speed and velocity and know their formula, and lastly, enumerate the different types of velocity. In the previous video, we have already discussed how to determine the displacement of an object traveling in a straight line. But our problem right now is that we still do not know how to calculate an object's displacement if it changes direction, which will not create a linear path. So we have to evaluate the displacement of two vectors that form a right angle to each other. And it may sound like a lot of work, but actually, all we need is the Pythagorean Theorem. Pythagorean Theorem is a mathematical equation which is used to relate the length of the sides of a right triangle to the hypotenuse of a right triangle. The equation is a squared plus b squared equals c squared, where a and b correspond to the length of the two sides, and c corresponds to the length of the hypotenuse. It does not matter whether a is the height or b is the base, or vice versa. In physics, the triangle can represent the path taken by an object, and the displacement can be represented by its hypotenuse. The equation is used to determine the displacement by adding the two vectors, and the sum of these vectors is called a resultant displacement. Just a little trivia. It was Pythagoras, or Pythagoras, a Greek mathematician, who first discovered and studied the properties of right triangles. The theorem, therefore, was named after him. So to try the Pythagorean method, let's try applying it in a problem. For example, you are hiking. When you reach the camp where you're expected to stay temporarily, you decide to hike further. You left the camp and walked 8 kilometers north, then turned 6 kilometers east to follow the route. What is the resulting displacement over your travel from the base camp? This problem seeks to determine the sum of adding two displacement vectors. The northward and the eastward displacements are at right angle to each other. So to determine the resultant, we will use the formula a squared plus b squared equals c squared, where a is equal to 8 and b is equal to 6. To find c, we will add the square of a and b and find the number root of the sum. So c equals the square root of 8 squared plus 6 squared. That will be c equals the square root of 64 plus 36. 64 plus 36 is 100, and the square root of 100 is 10. The resulting displacement is 10 kilometers. And that's it. We already know how to calculate displacement in a linear path and displacement derived from two vectors. But before we move on to another topic, let me introduce to you first the base quantities and derived quantities. Base quantities are fundamental quantities that cannot be defined in terms of other quantities. Examples of which are length, mass, time, electric current, temperature, amount of substance, and luminous intensity, which belongs to the 7 fundamental SI units. Derived quantities are defined based on a combination of base quantities. They are calculated from 2 or more measurements. Examples are volume, density, speed, Newton, energy, and pressure. Now let's further discuss the derived quantities that can describe the motion of an object. Because when there is motion, there is movement and also speed, and we can tell which object is moving faster by just observing how fast it moves. The speed of an object describes the rate at which an object changes its position in a given time. It is a scalar quantity, so the direction is not considered. It is defined as the total distance covered divided by the time traveled. So speed equals distance traveled, time elapsed, or time elapsed. An object moving with a high speed can travel a longer distance in a shorter amount of time compared to an object moving in a low speed. The speed is zero when the object stays at rest and when there is no movement at all. We can derive the formula speed equals distance over time by recalling the formula triangle involving speed, distance, and time. If time is unknown and the given data are only distance and speed, we will use the equation time equals distance over speed. If distance is unknown, we will use the equation speed times the time. In getting the average speed, the formula is total distance divided by the total time. For example, a man drove for 4 hours at a rate of 45 miles per hour and for 2 hours at 60 miles per hour. What was his average speed for the whole travel? Step 1. The formula for distance is distance equals rate times time. Total distance equals 45 times 4 plus 60 times 2 equals 300. Step 2. Total time equals 4 plus 2 equals 6. Step 3. Using the formula, average speed equals total distance divided by total time. The average speed is 50 miles per hour. Velocity, on the other hand, is a vector quantity that refers to the rate at which an object changes its position. It is a vector quantity, for it signifies both the magnitude and direction of the moving object. Velocity is defined in terms of displacement, which differs from speed, where total distance is used. The formula for velocity is displacement or final position minus initial position divided by the time elapsed. Elapsed time or time interval is denoted by t sub f minus t naught, where the difference will be the time passed during a particular event or duration. In getting the average velocity of an object, average velocity equals change in position divided by the time traveled, where v stands for velocity and the bar over is a standard symbol meaning average. Delta x is the displacement and delta t is the total time. X sub f and x naught are the initial and final position. T sub f and t naught are the starting and ending time. For example, the position of a runner as a function of time is plotted as moving along the x-axis of a coordinate system. During a 3-second time interval, the runner's position changes from 50 meters to 30.5 meters. What is the runner's average velocity? This problem asks to find the average velocity. The displacement is 30.5 meters minus 50 meters equals negative 19.5 meters. The elapsed time or time interval is given as 3 seconds. The average velocity is negative 19.5 meters divided by 3 seconds equals negative 6.5 meters per second. The displacement and average velocity are negative, which tells us that the runner is moving to the left along the x-axis. So the runner's average velocity is 6.5 meters per second to the left. Velocity is also classified according to its types. The different types of velocity are constant velocity, changing velocity, instantaneous velocity, and terminal velocity. The first is the constant velocity. Objects with constant velocity don't change their speed or direction. These objects are often traveling at a steady speed through a horizontal path. Second is the changing velocity. An object that depicts change in velocity shifts its directions and changes its speed. Objects can change its velocity in various ways. It can slow down, speed up, or change direction. Third is the instantaneous velocity. Instantaneous velocity describes the rate of change of position from an infinitesimally short time interval. It also determines how quickly an object is changing its speed and direction at a particular point where time interval and displacement is approaching zero. And lastly is the terminal velocity. A terminal velocity describes the movement of a falling object in the atmosphere, which is not influenced by external factors and has two forces acting on it, the weight and air resistance. It is the point at which air resistance is equal to the acceleration caused by gravity. Then the falling object falls at a constant velocity. For a recap of today's discussion, let's take note of the following formulas: the Pythagorean Theorem, the triangle formula consisting of speed, distance, and time, the formula for the average speed, and the formula for the average velocity. We must also remember the difference between speed and velocity. Speed is a scalar quantity which does not involve direction, while velocity is a vector quantity, which means that it is defined by the speed of an object in a particular direction. Velocity is defined in terms of displacement, while speed is defined in terms of the total distance covered. And that's it for today's video. See you on our next trip, StudyBuds.